So Chapter 8 is talking a lot about some statistics, and in 8.1 we're talking about measures of center and variation. So we have three terms we're going to talk about. The first one is the mean. So the mean of a numerical data set is the sum of the data divided by the number of data values, and the symbol X bar represents the mean. So another word for mean would be average. So you're just going to add up all your numbers and divide by how many you have. The median is the middle number when your values are written in order. So you want to go from small to big. And then when you have an even number of values, then your median is the average of the two that are in the middle. The mode of a data set is your value or values that occur most often. So if I had like 3 2s, and that was the most of one number, that would be my mode. So there may be one mode, no mode, or you can have more than one mode. An amusement park hires students for the summer. The students' hourly wages are shown in the table. So our first order of business is to find the mean, median, and mode of our hourly wages. So these are all of our hourly wages. We have 8 of them. So what we're going to do is I'm going to go ahead and put them in order. That way I have that done. So when you put them in order, you're going to start with the smallest. So our smallest value is $8.25. And I'm going to mark that off. And then I have another $8.25. All right, our next value is $8.45. $8.65. $8.75. $9.10. $9.25. And $16.50. So I've put them in order from least to greatest. All right, and the first thing I'm going to do is find the mean. That's the average, and we denote that with the X bar. That means I'm going to add all of them up and then divide by how many I have. Well, I already counted that I have 8. So whatever the sum is, I'll divide it by 8. So if I add up 825 plus 825 plus 845 plus 865 plus 875, blah, 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 all right, that's going to give me 77.2. So I've added all of them up. I'm going to divide that by 8 because I have 8 of them, and that's going to give me $9.65 is my average hourly wage. All right, now we'll find the median. So the median is the number in the middle. So if I have an odd number of terms, there is exactly a middle. But since we have 8, if I counted towards the middle, half of 8 is 4. So if I went 1, 2, 3, 4 in, and 1, 2, 3, 4 in, the middle would be in between those two numbers. So what I'm going to do is I'm going to take those two numbers and add them together. Now I cannot stress enough that if you have an odd number, it would be whatever number is right here. You wouldn't have to average. So you only have to average the two numbers in the middle when there's an even number of terms. So I'm going to add those together and divide by 2, and that gives me $8.70. That's the middle of my data set. And then the mode. Remember, the mode is the number that occurs the most. Well, I have 2 of the 825s, and then I don't have more of any other. So 825 is the mode. So that hourly wage occurs the most. So you have your mean, median, and your mode. Part B, which measure of center best represents the data? And then we're going to have to explain why. Well, if you look at your average, 965, if I kind of put that where it would go right here. And that is way higher than all my other data. So that's not a very good representation of my data set. I have the median is 870, okay? And then my mode is 825. Well, that's way down here, way lower than most of my data set. So the median, that is the best representation of my data. And the reasoning for that is because the average, or the mean, is above most of the data. And the mode is below most of the data. A water park hires students for the summer. The students' hourly wages are shown in the table, so we have some kids working at a water park. And we're going to do the same thing we did in number 1. We're going to find the mean, median, and mode of the hourly wages. So, again, I have 8 of these, and I'm going to put them from least to greatest just right off the bat. So my smallest wage is $8.15. Then $8.25. And the reason I mark them off is that I don't want to forget that I've already written that one down. Then I have 2 of the 8.50s. So 8.5, 8.5. Then 8.7, 9, 9.2, and 14.5. So 1, 2, 3, 4, 5, 6, 7, 8 of them. So to find the average, I will add all of them up, and I will divide by 8 because that's how many I have. So when you add them all up, you have 74.8, and we're going to divide that by 8, which gives us an average of 9.35. So $9.35 is the average hourly wage. Then we'll find our median. Well, I have an even number, so I know I'm going to have to go in 4, right? 1, 2, 3, 4. 1, 2, 3, 4. So the middle would be right here. So I'm going to have to take these two and average them. So 8.5 plus 8.7 and divide that by 2, which gives us a median value of 860. And then your mode, if you look up here, we have 2 of the 850s, and that's the most we have of any number. So $8.50 is the most common hourly wage. All right, part B, which measure of center best represents the data? Well, let's look at our average here, the mean is 935. That would be up here. That's way above most of our data values, so that's not a good fit. All right, the median is 860 and then 850. So both are right here, so both of them are a good representation. So we'll say median and mode. You can choose more than one if they're really close. And the reason is the mean is above most of the data. An outlier is a data value that's much greater than or much less than the other values in your data set. So we're going to look at the data in example 1, and they want us to identify the outlier. Well, these are all pretty close, but if you look at the 1650, that is way above every other piece of data. So our outlier would be the 1650. And then it says, how does the outlier affect the mean, median, and the mode? Well, in order to figure that out, we would have to remove the outlier and see how our data shifts. All right? So we need to find the average of that set of numbers without the 1650. So when I added them all together, I got 77.2. I want to take out the 1650. So if you take out the 1650, that would be 77.2 minus 16.5. That's going to give me 60.7. And then instead of dividing by 8, since we removed one value, we will divide by 7. That would give us $8.67. All right, so if you look back at your data here, our average with the 1650 is 9.65. So if I look, taking the 1650 out decreases 98 cents. So our average decreases 98 cents when we take out the 1650. Let's talk about the median. The median is in the middle, right? Well, now that we have 7 terms, if we take this term out, the middle is now the 865. Because think about it, I'd still go 4 in. 1, 2, 3, 4. And from this side, 1, 2, 3, 4. So this is the center, because I have 3 on this side and 3 on that side. So 865 is now my median. Before, the median was 870. So if we remove the 1650, our median drops to 865, which is a decrease of 5 cents. I don't like the wording on that, so let's change it to decreases. When we take the 1650 out, right? And then the mode, if we've taken out the 1650, that doesn't change the fact that 825 is still listed twice. So that would be 825, and that did not change, so it stayed the same. All right, part B. Describe one possible explanation for the outlier. So why would this person be making way more money than everyone else? So they're working at an amusement park. They're all students. So why does this person get paid more than everybody else? In fact, in some, it's like double. Well, there could be reasons for that. Maybe that person has more responsibility. Perhaps that person is more of a manager type person, or instead of like someone who might just be running one ride or something like that. All right, so number 4, we're going to consider the data in example 2. We're going to identify the outlier in example 2. So if I look at all of my data set, the one that sticks out on either end would be the 1450. That is way above all my other data. So 1450 is my outlier. All right, and then how does that outlier affect the mean, median, and mode? Well, let's talk about the average. So if I was going to average these numbers together, when I added all of them up, I got 74.8. So if I take away the 14.5, 74.8 minus the 14.5 gives me 60.3. And I no longer have 8 terms. If I take that out, I only have 7. So if I divide that, that gives me $8.61 as my average. So removing the outlier, I was at 935 for the average. I'm now at 861. So that decreases the average by 74 cents. All right, for the median, I now only have 7 terms, right? I've taken this one out. So I'm going to go 4 in. I always go up 1 to 8 and still do half of 8. All right, so that's 1, 2, 3, 4. 1, 2, 3, 4. So this is my middle. Notice there's 3 on the left and 3 data points on the right. So 8.5, and my median was 8.6. So if it was 8.6, that decreases by 10 cents. So if I were to put the outlier back in, it would increase by 10 cents, right? If I take it out, it's decreasing by 10 cents. And my mode, which was originally 850, is still 850. I still have 2 of those, so there's no change there. All right, for part B, describe one possible explanation. Same thing, right? These people are still working at the park, an amusement, a water park, right? So this person probably might be in a manager position, or they might be over several of them, and that's why they make more money. So again, still, it may be more responsibility, could be one reason. A measure of variation is a measure that describes the spread or distribution of a data set. One measure of variation is the range. The range of a data set is the difference of the greatest value and the least value. All right, so in this table, we have 2 reality cooking shows that select 12 contestants. So I have 12 contestants for show A and 12 for show B. The ages of the contestants are in this table. Find the range of the ages for each show and compare your results. So for show A, we're just going to take the biggest, the largest age of the contestant, which is 31. And then we're going to do the youngest, which is 19. We're going to subtract those. So the oldest contestant minus the youngest contestant, which gives us 12. So there's 12 years difference in the oldest and youngest contestant for show A. And for show B, we're going to do the same thing. So the oldest contestant is 48, and the youngest contestant is 19. So 48 minus 19 is 29 years. So obviously, if we were comparing our results here, so the show B, their participants are more spread out in age, right? There's 29 years between all of them. So the participants ages in show B are more spread out. So we have a larger range of ages for show B. After the first week, the 25-year-old is voted off show A, so that one's gone, and the 48-year-old is voted off show B. How does this affect the range of ages in the remaining contestants on show A? Well, this was in between the 31 and 19, so show A, that stays the same. So the range has not changed. But for show B, they took off the oldest contestant, so now our range is going to change. Now that the range for show B is no longer 48 to 19, the largest age we have is 32. So for show B, the range changes to 13. And that's because 32 minus 19 is 13. So now the show age ranges are roughly the same now that we don't have the 48-year-old in show B.